Assalamualaikum warahmatullahi wabarakatuh. Today, my group and I will be presenting our lab report project for the Smart Manufacturing course. Our project focus on the design and 3D printing of a functional product called the Pistachio ball. So, 3D printing is an important technology in smart manufacturing because it allows products to be designed digitally and produced efficiently. So this project was prepared by a group of 4 students where we worked together on design, slicing, printing and evaluation and using Tinkercad and a Bamboo Lab A1 3D printer. We designed and produced a functional product called a Pistachio ball, which aims to improve convenience during snack consumption. Next problem definition. So the main problem we identify is that when eating pistachio, the empty shells are often mixed with the edible nuts. So most conventional balls only have one compartment, so users need to place shells elsewhere, which creates a mess and interrupts the eating process. Therefore, there is a need for a simple and functional solution to separate pistachio and their shells in one product. Next is objective. The objective of this project are to design a functional pistachio ball using Tinkercad and apply suitable dimension and tolerance. We also aim to prepare proper slicing setting using Bamboo Studio, manufacture the product using the Bamboo Lab A1, and finally evaluate the print quality and functionality of the final product.
This slide shows an overview of our product. This product is called Pistachio Ball. This product was designed using Tinkercad and works to separate edible snacks from their discarded shells and also to prevent littering. Our product has two components and the material for making our product is PLA. The design process is carried out using Tinkercad software. The first version is our original idea where there is only one component and the component cannot be separated. This makes it difficult to remove the waste that has been put in through the hole in the ball. So after we overcome the problem, the improved version was born where this product has two components and can be separated. This makes it easier to dispose of the waste that is inside. So we added a handle to the ball for easy holding. This slide shows simple engineering drawings and dimensions of the internal and external components of our product. All measurements are set in millimeter units to ensure accuracy during the 3D printing process. As for the internal components, the overall diameter is 134.23 with a height of 59.27 millimeter, while the external component has a diameter of 150 millimeter and a height of 90 millimeter. A clearance of 0.5 millimeter is used to ensure that both components can be fitted properly without being too tight or loose. These dimensions help ensure that our project can be printed, assembled and used properly.
Several design considerations were considered to ensure that Pistachio Ball is functional, durable, and suitable for 3D printing using the Bamboo Lab A1. For tolerance, proper tolerance were applied in the design to ensure accurate printing and smooth dimensions. A tolerance range of 0.2 until 0.5 mm was considered sufficient for fused position modeling, 3D printing, helping to prevent dimensional inaccuracies and rough edges while maintaining good fit between compartments. The second one is infill. An appropriate infill percentage was selected to balance strength and material usage. A moderate infill level was chosen to provide adequate structural support for the bowl while keeping the printing time and material consumption reasonable. And the last one is material selection. Polylactic acid, which is PLA filament, was selected as the printing material due to its ease of printing, good surface quality, and low warping characteristic. PLA is suitable for household products such as snack bowls and provides sufficient strength for normal use. So in this section, I'll walk you through the slicing settings I use in Bamboo Studio for our 3D print. Let's see how each setting affects the final results. First, the layer height is set to 0.2 mm, which gives a good balance between print speed and surface quality. The seam position is set to align so the starting point of each layer lines up, resulting in a cleaner surface finish. We have two wall loops to strengthen the outer shell. The top and bottom shells have 3 layers each, providing solid surfaces, while the shell thickness is currently set to 0, relying on the number of layers for strength. The sparse infill density is 20% using a rectilinear pattern. This gives internal support while saving material and printing time. The internal solid infill also uses a rectilinear pattern for consistent strength throughout the model. Supports are enabled using 3 types structure, which reduce material use and are easier to remove. The threshold angle is 30 degrees, so overhangs steeper than this get support. Supports are applied only on the build place, avoiding unnecessary scaffolding as well. A 5 mm brim is added automatically to improve bed adhesion. The brim object gap is 0.1 mm, allowing it to stick without being hard to remove. For top and bottom surfaces, a rectilinear pattern ensures uniform layering. The paint penetration layers are set to 3, which improve bonding and give a smoother finish. Overall, these settings balance print quality, strength, and efficiency, resulting in a reliable and visually clean 3D print.
Hi, my name is Roberta Adawe Binti Mama Yasmin. My matrix number is 1231033, and I will be presenting the print results and the troubleshooting for the Pistachio Bowl project. So for the print results, the Pistachio Bowl was successfully printed by using the Bamboo Lab A1 3D printer with the PLA filaments, and our lecturer, Dr. Shahino, assisted with the printings, ensuring the correct setup and smooth results. We printed the bowl twice using 2 different colors to demonstrate the customization possible with 3D printing. So both prints came out without defects, and the surface were smooth, and the compartments have effectively separated the pistachios from empty shells. The base was also stable, and the overall structure was strong enough for regular use. So overall, the Pistachio Bowl functioned as intended and successfully met the objectives of the project. Since the printing was successful, no troubleshooting was required. However, we did identify several potential improvements for future versions. For example, we could use a lower layer height so that it could create a smoother surface, and we could also increase the infill to improve durability. Other than that, a sloped shell compartment could also make the shell collection easier, and by adding a grip or a texture edge, it could really help improve our handling. And lastly, we could also use multicolor printing so that it could visually separate compartments more clearly. And I believe that this adjustment could further enhance both functionality and also aesthetics.
So, in conclusion, our pistachio bowl was successfully designed, printed, and evaluated using smart manufacturing and 3D printing technology. So, the product effectively solved the problem of mixing pistachio with empty shells by using a simple dual compartment design. Through the use of Tinkercad, Bamboo Studio, and the Bamboo Lab A1 3D printer, we demonstrate the complete process from digital design to final product.